In the previous tutorial, I have developed a sketch to let two STM32 microcontrollers communicate and exchange data using React's LoRa modules. However, the developed code supported only one-way transmitter to receiver data exchange, and the communication distance was quite close. So we did not know how good these LoRa modules were in long-range communication. Today in this video, I will demonstrate the new added features to the LoRa driver that I have developed. And I will be sharing with you guys the long-range communication experiment that I have done to test the maximum range that these modules are capable of exchanging valid data over. Curious about the communication range that I've achieved? Then watch until the end. This video is sponsored by PCBWay. PCBWay is not only a professional and high-quality printed circuit board manufacturer, but they also have CNC cutting, 3D printing, metal sheet fabrication, and injection molding services, so it's the right choice where you can get all your project components from one single place. And they have $5 coupons for every new registered account, so don't miss this chance. Basically, it was important for the transmitter to know if its transmitted packet has been received by receiver or not, so it was necessary to modify the receiver code to let it send an acknowledgement packet back to the transmitter to let it know about the communication status. So now let's see how we can achieve this by modifying the code that we had developed in the previous tutorial. Alright, so let's start explaining the code running on the receiver side on the blue pill board that has STM32 F103 MCU, where I've initialized the UART peripheral to work over DMA, so the MCU does not spend any time trying to handle the received packets sent by the LoRa module, and we can see the UART reception over DMA starts using this function, receive to idle DMA. So what this function actually does is that it triggers an interrupt once a complete packet is received to the MCU and stored in the DMA buffer, and the RX line becomes idle. That's exactly where there is no more data being received over UART. So if we take this packet as an example, this packet is actually sent by the LoRa module to our MCU, where we don't know the size of it in advance. So in such a situation, the UART DMA idle callback will take place somewhere around here, right after 1 or 2 milliseconds of receiving the whole packets, and at that time the DMA buffer will be filled with the whole packet being sent by the LoRa module. This is perfect situation for us because the MCU won't spend any time waiting and handling the received packet. Alright, so let's get back to our code and carry on with the receiver task. So after receiving a complete packet over UART and the callback is triggered, this part of the code will be running. And as we have discussed in the previous tutorial, the received packet will be parsed, looking for ULoRa packet. And if the checksum of the packet is correct, this flag will be turned on. So we move to this part, where an acknowledgement packet is sent back to the transmitter, saying that the packet has been transmitted and received correctly without any problem. And after that, the green LED is turned on for 300 milliseconds. Now let's go back to the transmitter side and see the new sketch that I have added. Again, here we see the parser side looking for received packets to handle, and here we see the acknowledgement reception part. So here this flag is activated once acknowledgement packet is received from the receiver, and we see an LED is turned on for 300 milliseconds. And in this code segment, we see the ULoRa device count in one network packet is sent to the receiver. Once the onboard button is pressed, I have actually demonstrated this part in the previous tutorial. And now let me show you how the whole system works after adding the acknowledgement handling part in the transmitter side. Alright, so here we are with the logic analyzer interface. So this will be demonstrating the TX line, and this will be the RX line of the transmitter board actually. So let's zoom in and see the packet that we are transmitting at button press event. So this is the one that we have covered in the previous tutorial. And after that we see the module is sending OK back to the MCU, saying that the packet has been transmitted successfully. And after 150 seconds, we see acknowledgement packet that has been transmitted by the receiver, saying that the previously sent packet by the transmitter is valid after checking its checksum. So we see here the receiver address 1, and we see here the length of the transmitted packet, which is 1, in this case only 1 character, acknowledgement, and we see here the RSI -20, because the transmitter and the receiver modules are quite close to each other's, and the stand wave ratio is 11. And of course every field is separated with a comma. We see this over here. This helps us parsing the data within a packet. So now let me show you how this works in practice before going outside and showing you guys the interesting part of this experiment. Alright, so here we are with the transmitter and the receiver boards. The blue pill will take the role of receiver and the black pill will take the role of transmitter in our experiment. And here we can see the RYLR LoRa Module RYLR998 that we are going to use in our experiment. Both of these boards will be connected to a 5-volt power bank, so I can power them on the field. Alright, so now let me share with you a quick demonstration to show you how things are going to work on the field. So when pressing on the onboard button on the transmitter side, a LoRa packet will be transmitted to the receiver. The receiver will light up a green LED saying that your packet has been transmitted and its checksum is valid, and will answer with the acknowledgement packet. And when it is received by the transmitter, a blue LED will be lightened up, just like you are seeing right now. So now the communication is going on once I press on the onboard button. Alright, so now let me show you the location where I have done the long range test. You will notice that I live in Turkey, in Istanbul, a nice city, very beautiful city, but a crowded one. So I have done the test in 4 different locations, and my wife helped me accomplishing this experiment because I wanted to record both the transmitter and the receiver boards while they are communicating over LoRa. So our plan was to keep the transmitter static at one location, exactly close to a sea traffic tower, right over here. This place is called Üsküdar, and take the receiver board away from it and test it over a boat. Alright, so today I'm doing the long range test with my wife. My wife is sitting close to that sea traffic tower right over there. The distance currently between us is around 500 meters. And as you can see, currently the green LED is toggling. That means that the LoRa communication is going on. I'm currently going to the European side of the Bosphorus. Let's see how it goes. Alright, so the ferry that I took crossed the Bosphorus to my next test point, which is located in a place called Kabatash. And at this location I repeated the experiment, and here's the result. So I have just come to the European side of the Bosphorus, and as you can see the communication is still going right now. Yes, the green LED is toggling. The distance currently is above 2 kilometers actually. Yes, and as I've just said, my wife is close to the sea traffic tower right over there. This single transceiver, LoRa transceiver, is amazing. I mean, the distance is quite good. As you can see, there are no obstacles, no walls, which I think is a quite good environment for testing this module. Let's see, I'll try to go far away to test the limits of this module. Let's see how it goes. Okay, so after that I took a transportation and moved to my third testing point, where I've done the test again, and let's watch the result together. So here I am again with longer distance for the sake of testing this module. As you can see, here and then still the green LED is being toggled. The distance currently is around 3 kilometers. The transmitter is located close to this sea traffic tower, held by my wife, right? So still, as you can see, yes, the communication is currently going on. The distance, as I have said, 3 kilometers, which is good. Quite awesome, right? Yeah, so remember that the green LED is toggled only when the checksum of the received packet is valid. So it's not toggled at every packet, which is good, right? There's no corruption in the received packets, which is quite good. Awesome. So after that, I moved to my last testing point, which is located in a place called Eminonu. It was a very crowded place. It was hard to record videos over there. So now, hold your breath for the communication distance that I've reached. Alright, so here I am again with much greater distance. The distance right now is currently 4 kilometers. The sea traffic tower is right over there, as you can see. The communication is still going on. Here and then the green LED is being toggled, as you can see, yes. That's great. I mean, the distance is quite good. The testing environment is fine. So to tell you the truth, I could not actually reach the communication edge of this module because the city I live in is very crowded and it's hard to me to find an open area to have a better test environment. People who are living in Istanbul will know what I'm talking about. Anyways, the whole experiment thing was quite exciting to me and I hope it was exciting to you all guys. So actually in the upcoming videos I'm going to develop the code that I've worked on, the one that's interfacing this LoRa module, and build a very awesome project that I'm sure you guys are going to like, but I'm not going to reveal it right now, so stay sharp for that. Actually, this brings me to the end of this video. If you have learned something new, please tell your friends about useful electronics and share this video with them. Thank you for watching until the end, and bye bye.